Hello, everybody. These next lessons are 60 through 68, and they're all about graphing and your ability to plug in x values into functions, whether they are quadratic, linear, a cubic function, absolute value function, square root function, exponential. So keep that in mind as you're doing these. You're just plugging in numbers, solving, and then plotting them on a graph. It doesn't have to be harder than that. So let's get started. You'll most likely see tables, okay, X, Y, and tables will usually have numbers that you need to solve for something, and then they'll give you a function like Y equals X, right? If it's linear, just like this would be, then Y equals X means that for every X value, that's what the Y value is. So it'd be -2, -1, 0, 1. And if you were graphing that, then -2, -2, -1, -1, 0, 0, 1, 1, 2, 2, and so on. And then you can make your line. You can see that those are in a straight line, linear. One thing to pay attention to for linear is that there's no exponent located right there. There's nothing there. Which means it's actually, when there's nothing there, what's really there? It's not 2, it's 1. There's really a 1 there, it's invisible. But just, to keep that in mind, that's what makes this linear. And linear means line. Okay, so we're going to keep that in mind as we go on to the next bit. Okay, all right. If we take the next thing here and put a 2 on it, well, that's going to change all the y values, because what we're really doing is we're taking the x value and we're squaring it. So it's going to look like this. Y equals -2 squared. -2 times -2, and that's 4, and that's what goes here. -1 times -1 is 1, 0 squared is 0, and 1 squared is 1. And what you'll see here is, look right here and here. It's the same answer. So usually that's rare. Usually we don't see that when you're doing a line. So this is going to make a parabola. All right, I already have 0, 0 locked in here. But 1, 1, and -1, 1 are right there. And -2, 4 is here. And also 2 squared is also 4. So it looks like this. Okay. And I'll make it a little smaller so you can see. So it'll look like this, right? And then this is going to look like this. So, and that makes a parabola. So anytime you do a squared, if you see a squared here or something like that, you're going to make a parabola. A couple things to note. If it said y equals -x squared, it'd be the exact same thing, but opposite going down right here. So it'd be like this. And if it said y equals x squared plus 1, and you see this plus 1 here, what that means is it would not start at 0 anymore. It would start at the 1 on the y-axis. It would start right here. And then you would do each value squared plus 1. So -2 squared is 4, plus 1 is 5, so it'll be 2, 5. And 1 squared plus 1, 1, 2. See how it's all moved up? So it's almost like it's the same thing, but it was moved up 1. That would be doing this one. Okay. And if you put something like y equals 2 squared, or y equals 1/2 squared, x squared. We can even see those. Let's do this. Let's put them side by side. No, I don't want that. I want this. Okay. And let's do just a comparison. And within that, let's do a table for each of those so you can see x, y, x, y. By the way, your teachers in AGS1, they don't really like to use y a lot. They'll use something like f of x, which throws a lot of you off. Like I thought it was xy. The y is actually a function of x. So whatever you're plugging in for x, what spits out is the output, which is your y value, which is your function of x. So it's really just a fancy way. So anytime you ever see something like this, just know that that means y. And don't get scared of that. So anywho, so if I do, let's see, -4, -2, 0, 2, and 4. And then over here I'll do -2, -1, 0, 1, and 2. And all you're doing, again, you're going to square it first, then cut it in half for this one. Then you're going to square it first and times it by 2 for the next one. -4 squared is 16, and half of 16 is 8. -2 squared is 4, and half of 4 is 2. 0 squared and 0 is 0. They're both going to be 0. 2 squared is 4, but half of that is 2. And do you see what's happening here? Look at 8, 2, 0, 2, 8. They're repeating. It's going back the other way. That's actually a really good sign that I'm making a parabola, okay? If I don't get that, then I'll think I'm making something else. So it's really important that you choose some of the negative ones. You know, some kids your age, middle school, when they do their first ever, x squared function deal, they're just doing like 1, 2, 3, 4. Well, look what happens if you do that. You get 1, you get 4, you get 9, you get 16. Look at, so when a kid's graphing that, right? They get 1, and then 2 comma 4, and then 3 comma 9, and they think, oh, we got a line, and it's not a line because we have that squared there. So what this means is a kid didn't go back far enough to see that it actually is not a line. And how do you fix that is by simply choosing some negatives. So for when you get to some higher level math, right, AGS1, AGS2, and you get to some graphing, you're going to want to maybe start back a little bit and work your way up, and that's why you want to choose the numbers I'm choosing every time. And there's a reason why I'm choosing, like, for example, on this one here, I chose these numbers. There's a reason for that because I knew I'm gonna have to, I was like, I gotta cut these in half, so I don't want it to be 0.5s and stuff. And over here, I just kept with the same batch. So let's just do these real quick. So -2 squared is 4, and 4 times 2 is 8. And then -1 squared is 1, and 1 times 2 is 2. Okay. And 1 squared times 2 is 2. 2 squared is 4. 4 times 2. Okay. 8. So look at those real quick. Now you might think, wow, those are identical. But they're actually not identical. Look, that's different from this one. I'll get it. There it is. So let's graph those and I'll show you. So first I'll do the half, y equals half x squared. And if I do that one, what you're going to see is -4, 8, And what I'll do is I'll move this line down because I don't need it to be so. There's not going negative, so it's fine. Negative 4, 8. 1, 2, 3, 4, 5, 6, 7, 8. Negative 2, 2. 2, 2, and 4, 8. And then 0, 0. So, see that? Okay, now I'll do the other one in a different color so you can see how it differs. It's still 0, 0, but look at negative 2, 8. 2, 8. Negative 1, 2. And 1, 2. So something to think about is, wow, they aren't different. They are different. They're not the same. So meanwhile, the one that we did right here was 1, 1, 2, 4, right? The original 1, 1, and 2, 4. 1, 1 was here, and 2, 4 was here. So the original one, we call that the parent function. But look at the orange. So the red one, the orange is going to be the basics. The red one was the times 2. And so it's kind of a pattern, something for you to know is that the bigger the coefficient is in front, the skinnier your parabola is going to be. But if it's smaller than 1, like this blue one was, see how it's less than 1? It's 1/2. Then it's fatter. Okay, fat and skinny. Fat and skinny parabolas, big, wider, smaller. So you can imagine if it says 3x squared, it's going to be even skinnier. And if it says 1/4 x squared, it's going to be even fatter, right? So something to keep that in mind. All right, let's move on to talking about cubic functions. The parent function for cubic is y equals x to the third. And we'll get your table out. And actually what I'll do is I'll move your table over here. Cool. And then let's do x and then f of x, or just y is fine. And let's do -2, -1, 0, 1, 2. Again, when you're cubing something, you're taking that value and you're timesing it by itself 3 times. -2 times -2 is 4, but 4 times -2 is -8. -1 times -1 is 1, but 1 times -1 is back to -1. And then 0 times 0 times 0. And then here we're going to stay positive, but we're going to have the same numbers. So you see how these are not going to make a parabola. They do not make that shape. Let's find out what shape they do make. So -2, -8, -2, and then down 1, 2, 3, 4, 5, 6, 7, 8. -1, -1, 0, 0, 1, 1, and 2, 8. 1, 2, 3, 4, 5, 6, 7, 8. So if you look carefully, this coming in here, and then doing this deal. Okay, we can probably do a better job of that, but here, and then it's going to make this little s, and then go up this way. It's going to keep going. So they tend to have this kind of curve. And the curved piece is where it crosses over and starts to mirror its exact opposite, going the other way. So look for that when you do cubic functions. That's pretty much it. If I were to do a negative version of this, like y equals -x, how does that look? It's the opposite, so it'd be like looking like this. Okay, So something to consider to be going the other way. And same thing, if I add on a +1, it's going to move up 1. If I add a -1, it's going to move that way. And if I add coefficients, it gets bigger and smaller, same way. Absolute value functions. Absolute value, which, by the way, a little quick lesson on absolute value. This is one of those things that, like, sometimes we forget. We're like, what's absolute value again? The absolute value is the distance a number is from 0. So if this is 3, the absolute value of 3 is 3 because it's 1, 2, 3 spaces away. So the confusing part would be the kid who's like doing -4, and you're like, what's the absolute value of -4? A lot of kids say -4, but you're not going to have -4 spaces away. Just count the spaces. How many spaces away is it? It's 1, 2, 3, 4 spaces. So it's the absolute value of -4 is 4, which means no matter what number we ask you for the absolute value, it's going to be that same number without the negative. So that's what you have to remember. So the absolute value of 100 is 100, and the absolute value of -2001, 2003 is positive 2003 because it's 2003 spaces away from 0. So now that we got that figured out, graphing the absolute value of x. So it looks like this: y equals the absolute value of x, which means any number plugged in, we're just going to find the absolute value of that function, which means that we're just going to put absolute value of all those numbers. That's it. The absolute value. And I just told you they're all the same number except a positive version of it. So this is 2, 1, 0, 1, 2. Those go in here. 2, 1, 0, 1, 2. It's pretty simple, right? The absolute value graph is going to be similar to a parabola, except it's going to make a V shape. So it's a little different. So we have the 1, 1, the -1. We have the 0, 0. We have a 2, 2, a 2, 2. Okay, and then we have, let me undo that, it's cool. Going straight out and forever. Going straight out. So it's a little bit different. Okay. Don't worry, this is great. Because the absolute value of -3 is 3 and 4 is 4. So let's see how it's going to go forever. Yep. And of course, if I were to give you something like this, then it would be the same thing but going the other way. So keep that in mind if you get a -1. And then also if I add in something like y equals the absolute value of x +1, we are taking it up +1, and then it's still doing its thing. So you have a v that's a little, up higher by 1. So why am I showing all these? Because I want you to understand what they should look like when you get to those lessons. It's frustrating if you're not knowing what you're expecting. So if you do an absolute value function, you should be getting a v. Square root functions. So y equals the square root of x. A quick reminder on square roots. The square root of a number is the inverse of something being squared. So for example, 3 squared is 9. So not the square root of 9 is 3. See how it goes back like that? So keep that in mind when you're doing these. But the square root of a number. So if I tell you that we're doing square root values, okay, so let's do this. X, Y, and look at the numbers I choose, right? I know the square root of 9 is 3, and the square root of 4 is 2, and the square root of 1 is 1, square root of 0, 0, square root of, I can see those numbers. I know those numbers. Let me just put them in order. let's go like this. And then square root all those and get those answers in. Boom, 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 boom. I didn't choose 1, 2, 3, 4. I didn't choose -2, -1, 0, 2. So when I'm doing square roots, I want to choose something that's a little easier for me to solve. So when I'm graphing this, what does the graph look like? It looks like 0, 1, 1, 4, 2, 9, 3, and then you're just going to curve this and follow those points. It's going to go on forever. And what we're not going to get into are absolute values or square roots of negative numbers. We're not going to get into that because those are imaginary numbers, and there is a way to graph imaginary numbers, and you will graph imaginary numbers, just not right now, not next year, but AGS 2 or 3, that's probably coming your way. And if it doesn't show up in those, it'll show up in later math. At some point, you will graph imaginary numbers. And at some point, there'll be a teacher that says, all right, you need to memorize the square root of -1, which is I. And I is the first imaginary number. And it's something to figure out, and you'll have to go through that and do that, and good luck to you. And maybe you do get into it a little bit next year, but as far as graphing imaginary numbers, I wouldn't imagine that's something you do next year. But AGS1, they might introduce you to them and talk to you about them. I wouldn't be scared of it. Don't be scared of anything. So this is how you graph a square root. And they're always going to look like that. If it's like a negative on the outside, look what I do now. I'm going to put the negative right here. So let me put a negative in like this. That's going to change it up because now you do the square root of it, then you make it negative. So you do the square root of it, then you make it a negative, which all it does is make it go this way. So you'll have it go the other direction. And as far as manipulating with the +1 at the end, yes, it'll raise it up then or lower it. It affects where it's going to be located on the y-axis. Exponential functions. Exponential functions typically will look something like this. Starts out really small and then explodes. Okay. It doesn't typically start at 0 ever, really. If anything, it's going to start it'll hit the y-axis. A lot of times it hits the y-axis at 1. See that? It hits at 1. That's right there is a picture of exponential graph. What does it usually look like? Something like this, y equals 2x. See how it's different? 2 to the x power. And then what you're doing is your table is you're plugging in numbers like 2 to the 0, 2 to the first, 2 to the second, 2 to the third. 2 to the 0 is 1. That is something you need to remember. Anything to the 0 is 1. 2 to the first is just itself. 2 to the second is 4. 2 to the third is 8. So where's that at? 0, 1, 1, 2, 2, 4, and 3, 8. So this one's going to be looking like this, and up and up and up. So, and it does trail always kind of back here. And you can do 2 to the -1 power. And you can see you know what that is. 2 to the negative 1. And it's 0.5. So if you think about that, then negative, where is negative 1 comma 0.5, not 0.05, 0.5. And that would be located like here. So you can put some negative values in if you want. Up to you. I would probably try it if you wanted to try it, you know. Some people think that exponential graphs will start at this location, but they actually have a tail that goes really small, because as you get to a, you know, every higher negative number is just so small. But remember, things that are taken to negative exponent doesn't mean that they're negative. They're still positive. They're still always, it's always going to be above the x-axis. It's just going to be slightly above, like really small. That's it. There's your lesson, and I gave you one of each. Graphing functions. If you click on lesson 60, it teaches you and shows you a reminder of everything I just taught you, and then you're having to put some. You're not much work to do on this lesson. You're literally typing in what I tell you to type in, so you can see what it looks like for yourself. And that's that lesson, and you're trying out some for yourself so you can see the basics. It's all just for you to learn. And when you get to 61, that's a review because we spent the whole year doing linear relationships. These are real life linear relationships. So this isn't going to be just graph y equals 2x plus 3. It's going to say something like a real life scenario where the taxi driver charges you $3 to get into the cab, and it's $2 per mile, and then you have to know to make this from that information, and it shows you here and teaches you how to do it. So I don't need to go over that because it's all there. So 61 will walk you through that. It's a step up on what you've already learned. You learned how to graph regular equations. Now I'm putting those equations in a word problem. You have to figure out what the equation is and graph it. And as long as you remember that the initial fee is the, you know, y-intercept at the end, you're fine. And that the per mile is always your slope, then you're good. All right, thanks for watching.